Hey guys, so this is the first time that we, as an Algebra 2 class, have done an online set of notes, so I'm hoping that this will go smoothly. They keep turning the lights off on me here in the building, so I've got Steven here to help keep turning them on. I'm not going to put hard deadlines on your homework. I just want you to work on it as you can. Homework and notes will be attached on the website. Along with this video, and I won't say, okay, here's your assignment for this set of notes for the vertex form of a quadratic, and the homework is due tomorrow. What I will say to you though is, do not just watch the videos and then ignore the homework. You will be graded on the homework, but start sending me either pictures or whatever you want to do. Type it up in a Word document or a Google document and send it to me. Or if you just want to kind of work on your own separate sheet of paper and just wait till we come back and give it to me. I wouldn't recommend that, but if that's what you choose to do, that's fine. At the very least, though, try to take pictures of it, send it to me on Remind, or email it to me. But again, everything's going to be on the website. So we'll get through this somehow. This is going to be a learning curve for a lot of you, I realize, and so I will be patient, and I do want you to just ask questions as often as humanly possible. So you can see what we're talking about here, vertex form of a quadratic function. The vertex form of a quadratic is expressed as f of x equals a times x minus h quantity squared plus k. And we represent our vertex as hk. So whatever h is and whatever k is, that's our vertex. And x equals h is the axis of symmetry. We have talked about the axis of symmetry in this class already. X equals whatever the x-coordinate is of the vertex of that graph. And then our coefficient a determines the width and the direction of the parabola. So with the why we use the form, the vertex form shows the vertex on a quadratic equation in respect to its parent function, which we already should know is f of x equals x squared. And remember, that graph is a parabola that opens up. Vertex is centered at the origin, and that's all we have to do really with that. When we talk about parent functions, if you recall, I hope you still have the notes from the last time we were together, we talked about transformations and moving these functions around the graph. For number one, it says describe how each function compares to the parent function. Well, there's our x squared. That's for number one. That's our parent function, and then we're adding this 9 to it. If you remember, when we add or subtract on the outside of the function, in this case on the outside of x squared, it moves the graph up or down. So this graph gets moved up 9 units. The one directly below that, I'm going to skip number 2 for right now, come back to it, but the one directly below that, we're adding 5 inside the function. So this plus 5 actually shifts the graph left 5 units. Remember, it's the opposite of what you would think. You would think that the plus 5 would move it to the right, but it does move it left. And then the minus in front of the entire function reflects it over the x-axis. So over here on number 2, the minus 2, it's outside the function, so that's down 2 units. Number 4, we have the minus 4 inside the function. So similar to number 3, we did plus 5, moved it right or left 5 units. Minus 4 actually moves it right 4 units. And then the minus 1 is down 1 unit. For number 5, we have 1/3 x squared plus 2. So the plus 2 shifts it up 2 units. The 1/3 compresses it by a factor of 1/3. So remember, the graph looks like this, and if we compress it, it flattens it out. If we stretch it, it actually pulls it up some more, and we're going to see that here with number 6. With number 6, the plus 4 moves it left 4 units. The 2 stretches it and then the negative reflects it over the x-axis. So there we have just some basic transformations that we have already talked about previously. When we look at number 7, we're actually going to take transformations and create the graph. It says Mason graphed the parent function of a quadratic equation. So we know that the parent function of a quadratic is x squared. Then he reflected it over the x-axis, so that means we're going to have negative x squared. And then translated it 7 units up, so plus 7 outside of the function, 3 units to the right, minus 3 inside the function. What is the equation of the new parabola? So this transformed parabola is f of x equals negative reflects it. The x minus 3 moves it to the right, quantity squared because we're still doing a quadratic. And then we have the plus 7 outside of the function is what shifts it up. If you're still not clear on the transformations, please send me a message, let me know. I should have those notes already loaded on the website, but if not, I'll make sure they do get loaded where it shows all the transformations. It would be the previous set of notes related to this one. So when we look at number 8, give the vertex and axis of symmetry of each equation or inequality and then graph it. So remember, our vertex form is f of x equals a times x minus h quantity squared plus k. H and k is the vertex, and x equals h is the axis of symmetry. So in our example number 8 here, h is 2, k is 3. So we have the vertex is 2, 3. And the axis of symmetry is x equals 2. So when we plot this on our coordinate plane, we move over 2, up 3. This graph is not reflected, so it's just going to look, whoa, that's terrible. It's going to look like this. And I'm going to take just a quick pause here for a minute because I do want to go over to Desmos so that you guys can practice. You guys can use the tool at home since you most likely do not have a TI Inspire sitting around your house. So we have x minus 2 quantity squared plus 3. So I will go to Desmos right here. So it's desmos.com, and I want to graph x squared. Whoops, got a little ahead of myself. It is x minus 2 quantity squared plus 3. Okay, so there's our graph. You can see it over here on the right. I can also click on this point, and that shows me my vertex is 2, 3, which is exactly what we figured it to be. So I do want you guys to use the Desmos online graphing calculator to graph these, to check your work. You can download it as an app on your computer, or your phone rather. Again, just if you want to use your computer, just go to desmos.com. If you need assistance in using Desmos, please let me know. I can create tutorial videos to show you how to do different things if you need to do that. But for right now, just being able to type in the functions that you want to graph should be all we really need to do. Back to the notes here. So then on number 9, you can look at it and you can see that it doesn't have that x plus or minus something quantity squared, and then there's the minus 4. We can rewrite this as x minus 0 quantity squared minus 4, and now it's in the form of the standard form of a vertex form, rather the vertex form of a quadratic, where we have h is 0 and k is negative 4. So we can plot these points, 0, 1, 2, 3, 4. There's our vertex. The graph is not reflected, so we just draw our parabola opening up with the vertex at 0, 4. I'm going to do a couple more here, and then I'll post this, and then you guys can get started on your first NTI assignment with number 10. There's our h and our k. Now notice that the h is +5, so that actually means our vertex, the x-coordinate of our vertex, the sign is going to be opposite, okay? So if we had -5, then our vertex x-coordinate would be +5. So here it's -5, and our h, or our k value rather, is -1. So the axis is x equals -5. And so we go 1, 2, 3, 4, 5, and down 1. And notice that this graph is reflected over the x-axis because of that minus in front of it. So that means that that graph does open down. And there's our graph. Again, you can check that on Desmos to verify that we did graph that correctly, and I will go ahead and do that as well. +5 squared minus 1. So we have minus parentheses x plus 5 quantity squared minus 1, and there's our graph. Click on it, there's our vertex, -5, -1. So the Desmos should make life pretty simple. The graphs that you guys are going to do on this, the assignment associated with this set of notes is not going to be overly complicated. You just sketch your graph, at least get the direction correct. If it's compressed, make sure that you can kind of tell that it is compressed, or if it's stretched, make sure that you can tell that it is stretched. We'll see an example of stretch here on number 11. So for this one, if I just put a +0 on here, that kind of helps. We see that h and k, h is 4, k is 0. So our vertex is 4, 0. So that means our axis of symmetry is x equals 4. So when I plot these on the graph, this graph is not reflected, but that 3 in front of the parentheses does mean that the graph does get stretched. So when we talk about stretching, it goes from a kind of a wide parabola, the arms get closer together. So we're going to have something similar to this. The arms are a little bit closer together on that graph. We have a narrower gap in the parabola. I'll look at a couple of these, and then we'll be done. So with number 12, we're given a piecewise function. The first thing that we have is this graph that I'm going to do in pink. It's -1/2 x minus 6. So remember, I told you guys before, when you're doing a piecewise, graph the entire function and then erase what you don't need. So we have a y-intercept of -6, 1, 2, 3, 4, 5, 6, and a slope of -1/2. So that means we go down 1 over 2, down 1 over 2, and I get this graph right here. But notice the graph says that if x is less than -2, so that's going to split the graph right here where x is -2. The inequality is pointing to the left, so we're going to keep everything to the left of that line, which means this part of the graph we're keeping. We're going to erase all of this. The inequality is strictly less than, so we have an open circle. And then we want to graph the second part of the piecewise function. This one is a quadratic, and we can see that it has a vertex at +1 and -5. 1, 2, 3, 4, 5. And that graph will open up, and it's not reflected. So the graph is going to kind of look like, that was terrible, kind of look like this. But again, it's when x is greater than -2. So right here we're going to split the graph. The inequality is pointing to the right hand side, so we're just going to keep everything to the right of that split. So what we're keeping looks like this. And we have an open circle. So let me make a note of this, and I'm going to go to Desmos and write it down, or graph it so that you can see how to do the inequalities on Desmos as well. -1/2 x and x minus 1. Okay. So we go to Desmos, and I have negative 1/2 x minus 6. And let's see if I can remember how to do this with Desmos. Nope, that's not right. I'm just going to go ahead and graph that for right now. And then we have the x minus 1, quantity squared, minus 5. Okay, so there's our graphs for, and you can see when I sketched it on our notes, I should have actually had the parabola up here because we're cutting it off at -2. So we're keeping the left side of this line, and we're keeping the right side of this parabola from -2 over. And I will make another video later on that shows how to set the constraints for the inequalities that cuts off the graph where you need it. Go back to the notes. We'll do one more example and we'll call it a day. Let's look at number 15. Here's our h and our k. So our vertex is -1, -7. 1, 2, 3, 4, 5, 6, 7. This graph is not reflected, but it is stretched. So it's going to be kind of a narrow parabola. And f of x is greater than. So whenever it's greater than our parabola, we shade inside. If it was less than, we would shade everything on the outside. So that is a quick rundown on the vertex form of quadratics. I will post this along with the homework. If you guys have questions, send me messages on Remind, email me, do whatever you got to do to get in touch with me. But like I said, no hard deadlines on the homework. Just make sure you are doing it. Don't come back to school in a couple weeks with no homework to turn in. If you get it done, best suggestion, take a picture of it, send it to me. That way you know it's turned in and I can go on and get grading going. And that way when we come back, I don't have 80 papers to grade per assignment for all of you. So I hope everybody's doing well. If you need anything, you know how to get a hold of me, and I will talk to you again tomorrow.